Alright, so here's a simulation of the CRS-10 launch as seen by my telescope. First of all, here is the inside of the Dragon in the simulation. And I'm just going to confirm that I set the correct mass for the inside of the Dragon, which is 2,490 kilograms. Now we come into the Falcon 9 rocket and check the autopilot settings. All looks pretty good here. I don't know the exact amount of fuel that they reserved for the landing. This shows the estimated amount required to reach the landing site after dropping off the second stage. So I gave it a bit of a safety margin there. I don't know how much of a safety margin SpaceX actually gave their rocket. So this is a little bit approximate, but that's generally the deal. So here's the outside view of pad 39A. The model is actually for pad 40. I don't have the mesh for pad 39A, but that's purely cosmetic. The actual positioning of the rocket is correct on pad 39A. So now we'll wait for the correct time for launch. The autopilot will start a 10-second countdown from the time I engage it. So I'll proceed to T-minus 10 seconds. I should also point out that the space station is correctly positioned in orbit as well. Okay, coming up on T-minus 10. Autopilot engaged. I'm going to come over to my observing location. And tell it to track the rocket. Now, of course, the day that the launch actually occurred, it was quite cloudy and hazy, so I wasn't able to see most of the launch, but this will show you a view of approximately what the telescope would have seen had it been a perfectly clear day. Okay, now I need to target the first stage. There we go. You can see the second stage moves on down out of the bottom of the view as it continues on to orbit around the curvature of the Earth, and the first stage flips over to start its boost back burn. I should point out that I believe this version of the autopilot performs the slow flip that the first stage originally performed on its boost back burns. They now perform a faster flip so that there's less time before they engage that boost back burn, and consequently the first stage of the rocket is closer to its landing site when it engages that boost back burn. The boost back burn is now engaged. It's hard to see. Orbiter's not really designed to render objects this far away, but the telescope MFD mod that I'm using is allowing me to zoom in on the extremely distant first stage rocket now, which is almost 200 kilometers away from the observer location on the ground, which again is where I was located with my telescope for CRS-10. Boost back burn is now completed, and the rocket is reorienting itself for re-entry. The entry burn has now begun. At this time, the rocket was basically in the clouds. A few people managed to glimpse it for a brief moment between the clouds during the entry burn, but I didn't get a chance to see that. I was waiting near the landing site with the telescope at this point because I knew it would become visible shortly before landing due to all the cloud cover. I figured I wouldn't be able to see it until it got pretty close to the pad, and indeed that was the case. It was not visible for quite a few seconds after it started the landing burn, and was only visible for the last few seconds right before touchdown. Landing burn has now started. Landing legs are coming down. And finally, the rocket comes to a safe touchdown. And as you can see, the rocket's logo is not really visible in this case from my telescope's perspective, and that's exactly what happened during the actual landing. Now if we go to the second stage, you can see just now it stopped its burn. It's now in orbit. Zoom out with that field of view.